In this section, we'll learn two other methods for solving systems of equations. They're algebraic methods because they don't involve graphing the equations. So first method that we'll talk about is the substitution method. First step in this is solve one of the equations, doesn't matter which one, for one variable, and again, it doesn't matter which one, just pick an equation and pick a variable. Then substitute for that variable in the other equation, and in many cases you can solve for the remaining variable. We're going to solve for that variable and then replace that value in the other equation and solve for the remaining variable. That's a lot of words. So let's see how that works in real life. Okay, so we have two equations. I'm going to encourage you to use what I call the two-column approach to this. So y equals 1/3 x minus 5 and y equals 1/6 x minus 3. So we want to pick one of the equations to solve for one of the variables. Well, the good news is both equations are solved for y. So I'm just going to pick this one. And then we're going to take that equation and we're going to replace the y in that equation with 1/3 x minus 5, since y is equal to 1/3 x minus 5. Now what we have is a single variable equation that we can solve very easily for that remaining variable x. So this has fractional coefficients. Remember, with fractional coefficients, you probably want to go ahead and clear the fractions. So I'm going to multiply both sides of the equation by 6, which is the least common denominator. So 6 times 1/3 is 2, 6 times 5 is 30, 6 times 1/6 is 1, so we've got a 1x, minus 3 times 6 is 18. Now we can subtract off x, and then we can add 30, and adding 30, that gives us an x value of 12. Now what we're going to do is we're going to take what we did in this column and we're going to bring it back over to the other column, and we're going to replace the x in this equation with the number 12. So y equals 1/3 times 12 minus 5, which is y equals 4 minus 5, y equals -1. The last thing that we're going to do is write our answer in ordered pair form. Ordered pair form is x, comma, y. Now you can certainly write out a check for this one, but what this is saying is if I replace x with 12 in either one of the equations, I'm going to get a y value of -1. So let's take a look at the first equation right here. 1/3 times 12 is 4, 4 minus 5 is -1, check. Second equation, 1/6 times 12 is 2, 2 minus 3 is -1, check. So that's an important part, right? We want to make sure that our solution is correct. This gives us a way to determine if it is correct. All right, let's take a look at one more example of this type. This is set up a little bit differently, but again, I think it's real helpful if we just take our two equations and we just write them one at the top of each column. So we have a two-column approach. Now, we're going to pick one of the equations, and again, it doesn't matter which one, to solve for one of the variables. An observation, something you should be aware of, don't necessarily do it the same way every single time. Do what's easiest. And look for that variable that has a 1 coefficient on it. And in some cases, you might have multiple variables, right? So there's definitely multiple easier ways to do this. But I'm going to pick that second equation and I'm going to solve it for x, because all that involves is just adding 3y to both sides of the equation. Once I've done this, I'm going to take that first equation and we're going to replace the x with 3y plus 4. So that's 2 times x plus 3y equals 14. Now let's go ahead and do some distributive property here. Combine some like terms together on the left side of the equation. Subtract off that 8. and then get y equal 6/9, which reduces to 2/3. We always want to simplify our answers. And we're going to take that result and we're going to replace the y in that second equation with the number 2/3. So x equals 3 times 2/3 is 2, plus 4 is 6. So it looks like we have an ordered pair 6, 2/3. Make sure that you put the x value first in the ordered pair and then the y value. So there's our solution, 6, 2/3. And we can also check this one as well, and you can write it down or you can just do a head check. 2 times 6 is 12. 3 times 2/3 is 2. 12 plus 2 is 14. Checks in the first equation. Second equation, 6 is x, minus 3 times 2/3 is 2, so 6 minus 2 is 4, checks also. All right, now we've got a second method called the addition or the elimination method. In this, you want to have your equations in what it's called standard form, ax plus by is equal to c, and then multiply one or both of the equations so that the coefficients of one variable are opposites. Think the least common multiple. Then write one equation below the other and add to eliminate one variable. And then from there, the rest of this process is very much like the substitution method. So what you'll notice in equation 1 is that we already have a pair of variables here that have opposite coefficients. The coefficient of y in the first is 1. And in the second equation, the coefficient of y is -1. So we're simply just going to add those two equations together. X plus x is 2x. Y plus -y is 0. And then bring down the equal sign. 5 plus 7 is 12. Make sure you add all the way across. So we have 2x equals 12. That's going to give us x equals 6. And from there, pick either one of the two equations, doesn't matter which one, so I'm just going to pick that first one, and I'm going to replace the x with the number 6. Since we just solved for x, so 6 plus y is equal to 5, subtract off your 6, and that's y is equal to -1. So it looks like we have an ordered pair solution of 6, -1. Make sure to write it as an ordered pair and put those parentheses around it. All right, let's check our solution. So in the first equation, the x plus the y equals 5. That's true, 6 plus -1 is 5. In the second equation, x minus -1, or 6 minus -1 is 7. That also checks. All right, that's probably the easiest type. It's already set up for you. There's a second type where it may not be quite as easy. We don't have opposite coefficients, but what we can certainly do is we can make those coefficients opposite by multiplying this first equation by -1. So I'm just going to simply bring over the first equation and then multiply all the terms in the second equation by -1. Make sure that you're multiplying all the way across, including the number on the right side of the equation. Now we're going to add those two equations together. X plus -x is 0. 4 plus -2y is positive 2y. And 1 minus 4 is -3. So we have 2y equals -3, and y is equal to -3/2. We can substitute into either one of the first two original equations. I'm just going to pick that second one because the numbers are smaller, or the coefficient rather is smaller. So x is the variable we haven't solved for yet, plus 2 times y, which is -3/2, equals 4. So 2 times -3/2 is -3, so x plus -3 is 4, and then adding 3 to both sides, x is 7. So it looks like we have an ordered pair of x equals 7, y equals -3/2. Make sure again to write your ordered pair with parentheses around it. All right, let's check out another. This one adds another level of complication. We can't just multiply one by a negative, but you might notice, for instance, that already our our y coefficients are opposite in sign, one's plus, one's minus. So we might think about the least common multiple of 5 and 2, which is 10. So the least common multiple of 5 and 2 means that we're going to multiply equation 1 by 2 to get that least common multiple, and the second equation by 5 to get that same least common multiple. So the result is 4x plus 10y equals 2. And then on the bottom equation, 5 times 3x is 15x, and then minus 5 times 2y is 10y equals 5 times 11, which is 55. Now we're simply going to add those two equations together, but because what you'll notice here is that our y coefficients are exactly opposite of each other, so they are going to add up to 0, and then we have to add up the remaining terms. 4 plus 15 is 19, 2 plus 55 is 57, so 19x is 57. Don't give up. Remember, 20 goes into 63 times, and 19 is 1 less than 20, and 57 is 3 less than 20. So this goes in even 3 times. Trust me, we're not going to be terrible with you on the numbers. They're not going to come out to awful fractions. Nobody wants a final answer of 57/19. It just happens to be a whole number, which is 3. So just try it, see if it works. All right, now we're going to take and replace the x value in either one of the two equations with 3. So I'm going to grab that first equation, and I'm going to replace the x value with 3. And 6 plus 5y is equal to 1. Subtract off that 6, and that gives us -5. So y equals -1. Looks like the solution is 3, -1. And again, we can check those in the original equations to make sure that they are correct. Let's do one more. In this one, we have two equations, and if we want to use the additional elimination method, what we can do is notice that the least common multiple of these two terms is 3, right? Because rather they're coefficients. Coefficient of x is 1, coefficient of 3x is 3, least common multiple is 3. So we can multiply the first equation by -3. That's going to give us -3x minus 12y equals -30. Second equation we can just bring straight over because we have opposite x coefficients. Add everything together. Now don't stop until you've added all the terms together and brought down the equal sign. -3x plus 3x is 0. -12y plus 12y is 0. -30 plus 20 is -10. What we get is an equation that says 0 is equal to -10. That is, in fact, never true. 0 is never equal to -10. So what that means is we have no solution because our two equations didn't play together nicely. If we came out with an equation that was always true, like 5 equals 5, in that case we would have an infinite number of solutions. And that is it.